Alright, so the next next crack that we have to show you guys is chemiluminescence. So a little introduction to this is if you guys watch any Law and Order, CSI, Dexter, that kind of thing, you'll find that a lot of circumstantial evidence that they can find is at the crime scene itself. And for any bodily fluids, they usually shine the light on it and you see like, oh, there's a fingerprint here, or there's bodily fluids over there, or something like that. Some kind of blood. So unfortunately, this looks like someone dragged their body out. So obviously, investigators like to use this technique. However, there's a couple of flaws, but I'll tell you guys about those flaws once this experiment is done. So just before we get this one going, just a little bit more chemistry again about what's actually happening. So we've got this substance here called luminol, which is in one of the flasks. This is green flask here. Oh no. I know. Yes. And what happens is we've got peroxide and a catalyst. And what happens is these little groups over here get replaced with oxygen with double negative charge, and it also ends up in an excited state. Once it's excited, it needs to relax back down to its ground state, and this gets given off as a light, a photon. So we go from the excited state to its ground state. So without further ado, and the catalyst can also is usually an iron compound. So haemoglobin is a good one because it's in our blood. But I'll talk a bit more about that. Take it away. Where's the light? Whoops. And I'll take the PowerPoint off too. There you go. So as the mixture is happening, you can see that it's obviously glowing. It's quite dependent on the flow rate because you want a nice mixture.